look at Unit 9A, check your understanding here. So I'm going to do this with some different colors along the way. First instruction here says to, in each of these graphs, circle the vertex. So vertex is that point where it changes from going up to going down or going down to going up. So those are the vertex in each of those. Draw a dotted line to represent the axis of symmetry. So the axis of symmetry, according to my notes, is a vertical line that passes through the vertex. So there is my vertical line passing through the vertex and making it as a dotted line through there. So this is the axis of symmetry. Sometimes they'll just call it the line of symmetry. They kind of depends on where you are and who you talk to as to what they want to call that. Draw squares around the x-intercepts. So x-intercepts are the places where the parabola touches the x-axis. So I've got one right there, and I've got one here. And on this one, there's one right there, and there's one right there, because this is my x-axis down here. Here's my x-axis, here's my parabola. They never touch, so there's nothing to mark for that one. Okay. And then draw a triangle around the y-intercept. So the y-intercept is the place where the graph crosses the y-axis. I think I see one right here. So there's my parabola touching the y-axis, parabola, y-axis, right there. Inside that triangle is where it happens. Parabola, y-axis. Got that going right there. Okay, so complete the table by approximating the locations of what we have marked. So the vertex of graph A, that's this one right here, looks like it is at -1, -4. This one, I'll go ahead and do all the vertices. Vertices is the plural of vertex. So 2, 12 looks like where that is, and this one is at 1, 2. Okay, the axis of symmetry, it is a line, and lines have equations, they aren't points. So equation for a vertical line is always x equals something, and the x that it's equal to, since it goes through the vertex, is the x coordinate of that vertex. So this is going to be an x is -1. This one is going to be all the x's on that line, all the points on that line have an x coordinate of 2. And all the points on this line have an x coordinate of 1. Okay. X-intercepts, these don't hit in real nice places. I'm going to estimate, and I'm going to write them in this other pencil so it's a little more visible there. I would estimate at about maybe -2.4, 0, and at about 0.4, 0. Anywhere in that neighborhood is just fine. This one is at -2, 0. This one is at 6, 0. Again, the x-intercepts are points, so it takes two numbers to name one point. Check my focus here again. Looks like it got off a little bit. And there are no x-intercepts on graph C. The y-intercepts, I do the y-intercept in the light blue there. This looks like that again is a point. So that's the point 0, -2. On here, this is the point 0, 9. I can notice that whereas my x-intercepts always have a y number that is 0, the y-intercepts always have an x number that's 0. And that one is at 0, 3. Okay, so this graph A, in terms of maximums or minimums, this one looks like it has a valley in it. So there's a low point in the valley that fits with the idea of a minimum. So I'm going to say there is a minimum there, and I'm even going to identify that it happens at y equals -4. The smallest output that I can get, my minimum value, is -4. This one is like a hill, so the top of the hill, that's the maximum, fits with that idea. And the maximum there is happening at y equals, looks like 12. And this is a valley again, so that looks like minimum. And the minimum there is at y equals 2. Okay. This one feels like this is the description of opening up. If you're having trouble figuring out what opening up, opening down means, this one is opening upward. This one is opening downward. This one is opening upward. Okay. And my range as an inequality, range is about outputs. So it's always going to be a description of y values. And this one, the outputs, there are no y values down here below -4. The only y values I have are greater than or equal to -4. Okay, so graphs with minimums, parabolas with minimums, open up and have ranges that look like y is greater than or equal to. The ones that open down have maximums, and they are going to have ranges that look like y less than or equal to. In this case, that's less than or equal to 12. This was an up, so it's a greater than or equal to, and that value that matches what this value was is a 2. All right, let's see if I can squeeze this in here. So, sketch a graph of a parabola with the following properties. We want a vertex at -4, 3, -4, 3. That is where that vertex is. And a y-intercept at -2. Stuff rolling all over the place here. Y-intercept at -2. Okay, so if I'm going to sketch that parabola, it looks like vertex, if it's got to go through that point, it's clearly going to open down. The axis of symmetry, or line of symmetry, whatever you want to call it, definitely always goes through the vertex, so I know it has to be right there. And the idea of symmetry would mean that this side of the parabola that's coming down something like this, if I were to try to sketch it in there, has got to have an identical piece over here. And so this, at this level where this gap is over here, 4 places, 1, 2, 3, 4, means that 1, 2, 3, 4 this way, this other side of my parabola should go through that point. Okay, so there's the graph of the parabola that has those properties. Now it's going to ask me this question: which of these points do you know for certain is on the graph? Probably that shouldn't be there. Okay, so, well, I marked this point at -8, -2, so that one, because of the symmetry, I know is definitely on the graph. My explanation might be something like symmetry acts like a mirror. Okay, that might be a reasonable explanation for what I'm seeing in there. My penmanship's coming apart here because I'm writing on the edge of the desk. See if I can move that up for the next one. So write the range of this function as an inequality. This is an opens down, so I know my range is going to start with a y less than or equal to, and it's going to be less than or equal to whatever the maximum value was. The maximum value here is a 3, so the range of that is y less than or equal to 3. Yeah, let's take a look back. Okay, sketch graph of the parabola with the following properties. It has x-intercepts. I was doing that with the green before at -1, 0. and at 5, 0, and it has a y-intercept at 0, -6. Okay, I think I can tell from this that if this is going to go through there and hit this one over here, then that's got to be an opens up kind of parabola. Let's see if I can figure out anything more about it. If there's going to be symmetry here, then the line of symmetry must be halfway between these points. So there's 1, 2, 3, 4, 5, 6 spaces there. Half of that is 1, 2, 3 spaces. So the axis of symmetry is forced to be right there. Okay. Which tells me also I can get another point over here. I can get a point right there by symmetry. I know my vertex is on this line somewhere, maybe down around here somewhere. So that gives me an idea of where to draw this side of the parabola and where to draw this side of the parabola. So I think that's what this parabola must look like. Which of these points is the only one that could possibly be the vertex? Well, I have my vertex at 2, -8. And 2, -8 is one of the choices. 1, -8 wouldn't fit the symmetry. 2, 2 is on the line of symmetry, but I wouldn't be able to go from here through these points and come back and get that y-intercept. It wouldn't be the shape of a parabola anymore. And 2, -6 would put me even with these points up here, and so I wouldn't be able to make the parabola shape there either. So my explanation there, again, is it has to open up and have x equals 2 as the axis of symmetry. I think that pretty much explains it. So what is the equation for the axis of symmetry? It's always x equals something. The x that it goes through here is a 2. All right, sketch graph of the parabola with following properties. The axis of symmetry has the equation x equals -2. So put my x equals -2 axis of symmetry in there. It has an x-intercept of -2, 0. So it goes through that point. It's interesting. And it passes through the point -4, 4. Okay, well that's enough to tell me that if that point's on the graph, then this point also has to be on the graph by symmetry across that. And I know my vertex has to be on the axis of symmetry, so this point must be my vertex. And so I'll sketch my parabola in like that. Which of these is the only point that could possibly be the vertex? Well, I've discovered that the vertex has to be at -2, 0, so that's the one. The vertex is on the axis of symmetry, and that is my only point that is on the axis of symmetry. And I do that in here. Okay. What are the exact coordinates of the y-intercept? Well, by this reflection here, I can see that this, so I could have marked that with blue as well. I'll put my blue triangle around there. That is my y-intercept, which is at 0, 4. Okay. All right, vertex of this next one is at 4, -1, so 4, -1, right there. The y-intercept is at 0, -5. That is right there. Since that is the x, or since this is the vertex, that means my axis of symmetry must be right there, and I can reflect this point across that line and get another point right there. It's enough to give me an idea of what this graph looks like. It clearly has to open down. I don't really have any other choice in the matter there. Okay. What can you say about the x-intercept? Well, where does this cross the x-axis? The answer is a big nowhere. Let's see. I should have marked that in. If I was consistent with my colors, that was going to be a blue there. Okay, there aren't any. Name one other point that we know for certain on the graph. That's that one right there. I know that 8, -5 has to be on the graph because of the symmetry. And the range, this opens down, so it's going to be a y less than or equal to, and it looks like it is less than or equal to -1.